Morning, good afternoon, good evening, and welcome to this webinar on how to ace algebra. We also call this Algebra 2 webinar. In this webinar, we talk about how do you solve the easiest to the most challenging questions in linear inequalities, absolute value, absolute inequalities, um, as well as absolute equations. It's a fairly application-focused webinar. One thing that we ask from you is that you go through, you have a bit of a foundation and then you know a few concepts in these areas. As long as you know a few concepts, we promise that that we will help you solve the easiest or the most challenging questions, and we will uncover the areas in which you falter. So you get feedback that is personalized to you. This is a fairly application-focused webinar, by the way, in case I did not say that already. Now, if you have not gone through the foundation concepts, they are still a part of your free trials. You can post this webinar, you can make sure that you go through these concepts. We also have some upcoming webinars. We have a free webinar on GMAT reading comprehension, which is next Saturday. If you haven't registered for the same, please do so. We also have a free Quant workshop. Think of it as a proctored mock test in which we not only evaluate where you stand on GMAT Quant, but we also help you build a personalized study plan that takes your strengths and weaknesses into account. Again, if you have not gone through this, definitely do that if you've not registered for these. Since this is a free webinar, I do ask a few leading questions just to make sure I can understand the makeup of this particular group. The first question that we ask is, when do you plan to take the test? The second question that we ask is, what is your current quant score? Let me bring in that poll question. Here it is. What is your current quant score? And then we'll talk about what is your target quant score as well. All right, while I get responses to my second question, let's get to the first one. In terms of when do people plan to take the GMAT, more than around about 55% of the class has ample time before the test, which means that more than 45 days. We have, other than that, we have about 3 similarly sized groups. One that has a GMAT right away, one that has a GMAT in 16 to 30 days, and the third group that has between a month to 45 days. All right. And with regards to the current quant score, the biggest group is those who are below Q30. The second largest group is those who are in the Q41 to Q45. And then we have a similarly sized group in the Q31 to Q40. So fairly good range of scores. You also have a few folks in the Q46, 48, one person in the 49, 50, and one in Q51. Let's kind of look at the target quant scores as well. And while we are at it, let's also get to know about your comfort level in algebra. How do you think you would fare in algebra if you were to take the exam right now before the webinar? Okay, let's get a few more responses. All right. In terms of comfort level in algebra, biggest group below 70%. And again, these are all in some ways objective, in other ways it's up to your interpretation. Below 70% would be where you're not comfortable at all. At 70% would be if you think you can do easy questions, and 80% would be if you think you can do medium questions, and if you're at 100 or higher, which means you think you can do pretty much any question that we can throw at you, as long as it's within the scope of the GMAT. You think you'd be able to solve it. All right, so we have about 85% of the class at 80% or below, but a good chunk of you are at 80%, a good chunk of you are at 70%, a few of you are below 70%. So that's good. That's a good challenge. So let's go into the presentation part, as we call it. So the screen should have changed for you or should be in the process of changing for you. And while the screen's changing, the beauty of this is when we get all of this data, it gives us insights as to the makeup of this group. It allows us to modulate the session somewhat, not a whole lot, but somewhat, so that we can adapt it to the needs of this group. So it tells us about your needs. So thank you for participating in the webinar. There's essentially three parts of this webinar. In the first part, I'm going to briefly go over an introduction to e-GMAT. In the second part, we'll go into the core of this session. And in the third part, once the core is done, we'll have an open-ended Q&A where if there are questions that we've not been able to respond to during this webinar, we'll be happy to do so. Now, we have some folks supporting us in this webinar. We have Komal Shah, who's a GMAT strategy expert, and she'll support us answering all your GMAT strategy related questions. We also have Ashutosh Mishra, who's a quant expert, and he'll help address your doubts over here as well. I want to thank both of them for taking time out on their Sunday evening to do this. My name is Rajat Sidana. I'm one of the co-founders, and I'm based in Phoenix, Arizona. So with that, let's start with an introduction to e-GMAT. Let's actually start with one other question, which is, what is your target GMAT score? And I think you guys responded to this. We did not address this, but essentially what you really see is about 65% of you are aiming for a score, or close to 70% of you are aiming for a score of 700 or higher, or 720 or higher. I'm sorry. It's about 70% of this group over here. Now, while about 70% of you are aiming for that score, I can tell you statistically only 6% of the people get to this score. And this is in a world where the median scores at top business schools continue to go up. And this is data from second half of last year, where you can really see how the median scores have moved compared to the same time period in 2017. What is it that people who get to those scores do? A good percentage of them do use e-GMAT. And then again, to really look at this data, there are two data points that you can really look at this. One is the number of verified reviews, and the second is the number of success stories. So when you look at these stats on GMAT Club, what you would really see is that compared to the other major prep companies, over the last 3.5 years, there have been more reviews for e-GMAT than have been for any of the other prep companies. Similarly, when you look at success stories, you're going to find a very similar story as well. Okay. So what makes our students more successful? I think there's one thing that I would point to that makes our students more successful is it's our approach to GMAT preparation. So when you think about the approaches, what you're going to find that today in the test prep world, you have two different architectures that prep companies follow. Well, one architecture is the classical book-based architecture, and the second architecture is the private tutoring-based architecture. When you look at most of the other prep courses out there and most of the other prep companies, what you're going to find is even though they provide audio-visual learning, they're predominantly based around this book-based architecture. When you evaluate e-GMAT, what you're going to find is that we are based primarily around this private tutoring-based architecture. So let's see, why is one architecture better than the other or more effective than helping you achieve that 720 or higher score? So let's take the case of a person who wants to get to that 720 score. So if you want to get to that 720 score from where you currently are, the first thing that you need to have absolute clarity on is a path to that goal. You need to know what milestones you need to hit to get to that 720 score. The second thing that you need to know is that you need to learn all the concepts that you don't know today. Then you need to learn how to apply those concepts. And while learning application, you need to attain that level of mastery that puts you in the among the top 6% of all test takers. As long as you can do this, you can be more or less certain that even though only 6% of the students get to that 720 score, you can be among those 6%. Take a look at these steps once again, and let's kind of really see how these approaches tackle these steps. So let's start with the book-based approach. So when it comes to study plan, and if you're studying using books, a book-based approach will give you a couple of study plans, but those study plans would not be personalized to you. The entire onus of personalizing the study plans would be onto you, and in most cases, those study plans would not be adaptable. So most of the times, people who follow a book-based approach either start just studying or take a study plan and start following that. Now then they go on to learn concepts, and there are a number of books that teach you concepts really well. While students learn concepts, the onus of validating whether they've actually learned the concept well enough is completely on the student. Books really don't do a great job of validating that for a particular student. One area where books don't do as well is teaching you how to apply those concepts. It's not because the authors don't know how to teach you application. It's just because of the static format of the book. It's very difficult to tell you what do you do in step 1, what do you do in step 2, what do you do in step 3 while solving a question. And when you falter, it's very difficult in a book-based architecture or a book-based format to point out where you faltered. And then as a result, people who follow this approach try and solve hundreds and hundreds of questions, and only the best and the brightest are able to master application. Lastly, when it comes to getting to that top 6 percentile of students, people who follow the book-based approach, they essentially take lots and lots of mock tests to really figure out whether they are among those top 6 percentile of students or not. So essentially, people who follow the book-based approach study a section, take a mock test, study another section, take another mock test, just to evaluate themselves. And again, even when they take mocks, the onus of what to do next is completely on the student. Now let's see how private tutor-based approach tackles these problems. When you work with a private tutor, the first thing that a good private tutor would do is to work with you to understand the areas that you're strong in and the areas that you're weak in. And essentially, for any of you who's worked with a good private tutor, you would have experienced that. The first couple of hours go on doing that, and then go on creating a study plan. Okay. Then a private tutor teaches you concepts, and while teaching you concepts, a private tutor evaluates you constantly and gives you feedback on areas that you need to work on. One of the biggest differences between a book-based and a private tutor-based approach is the extent of application that you learn. A private tutor, while teaching you how to solve questions, tells you exactly what you do in step 1, step 2, step 3, or how to approach a particular problem. And then, while teaching you application and giving targeted practice, a private tutor constantly evaluates the extent of mastery that you've attained, and then makes a decision as to when it's time for you to move from one topic to the other. So what is the difference between these approaches? While you learn the same content, the extent of personalization, the extent of feedback, the extent of methodical approach towards question is different between these two approaches. The private tutor-based approach is a lot more personalized. The transitions in a private tutor-based approach are a lot more logical. So let's see, why do we say that most of the other prep companies take a book-based approach while e-GMAT is built around this private tutor-based architecture. Let's take the same example now, put some numbers to it. Let's take an example of a student who wants to go from a 600 to a 720 score. The first thing that a private tutor does is to create a path, and that's something that we make you do as well. We make you choose a path towards that 720 goal. Now there are about 6 study plans or 6 different paths possible. For ease of understanding, I'm going to just highlight 2 different paths. One is what we call as a verbal driven path, where if your strength is verbal, this is the path that you would choose. The other is a quant driven path. Depending on what your strengths are, you could choose one of these paths, and we give you, we educate you on how to choose these paths. To look at our methodology on creating the study plans and study plans for 760, you can see some of the URLs at the bottom. We'll be sharing this PDF, so you'll have these with you. Let's take an example of a student who chooses this quant-driven study plan. Now, once you've chosen the quant-driven study plan, you then need to decide milestones to get to that study plan. So let's see, how would you get to a Q50 and a V38? because that's what you're targeting. So to get to a Q50, we again tell you the various milestones or various possible combinations in which you can get to a Q50. So let's say based on his strengths, the student chooses to do really well in arithmetic and do above average in algebra. Similarly, on the verbal side, the student chooses to excel in sentence correction, do really well in critical reasoning, and do slightly above average in reading comprehension. Now, some of you may be thinking, how do you get to these numbers? And we built a product called GMAT Planner that helps you work through these permutations and combinations. Powering this engine is a neural network that allows you to work through these combinations. And this is something which only we've built, and GMAT doesn't give you these data points. The reason we've been able to do that is because we have hundreds and hundreds of score reports that we've been able to feed to a data engine to get this output. Now, what happens when you do this, when you build these milestones? You personalize your GMAT preparation. So for example, in Quant, your GMAT preparation for algebra really has a starting point, which is where we help you figure that starting point out, and has an ending point. And you can really say this is what you're aiming for. Similarly, in arithmetic as well, you have a starting point and you have an ending point. And you can really say, to be among the top 6 percentile of students, these are the milestones that I need to hit. When you have that, it's a lot more deterministic. So this is just about the study plan so far. Let's talk about learning concepts. Remember, a private tutor would teach you concepts and then evaluate you on your ability to apply those concepts. This is a screenshot of one of the 50 modules that we have in our Quant course, and this is the divisibility and remainders module. Again, what you see is the two highlighted portions are video lessons in which we teach you concept, and in fact, on the next slide, I'm going to show you how we evaluate you on the concept as well. Now, compare that to a popular Quant course by Magoosh, and what you really see is that this is just a bunch of lessons. There's really very little feedback over here, and then there is no application. And so let's kind of look deeply into the lessons and see how they're structured. So on the next slide, what you're going to really see is how does a lesson within the concept file look? And what you see over here is beautifully laid out content, and this content is laid out with animation. So you see the right information coming at the right time. Every question, every concept has detailed videos with high definition audio. You also have practice questions right then and there. So you learn a concept, you do practice, we do evaluate you right then and there as well. So this helps you gauge your understanding. It helps you get feedback on areas where you still need to work on. Compare that to the same lessons in the Magoosh course. What you're going to find is it is audio visual, but essentially it's another form of not reading a book. Let's talk about application of concepts over here. And in the e-GMAT offering, every module has a dedicated application file, and where we teach you how to apply the concepts. And again, you get feedback as well. So you can see every application file gives you a specific score over here. And you get feedback on your ability to apply these concepts as well. Similarly, we also give you a set of targeted official guide questions that you can also apply these to. So basically, you learn a concept, you learn application, you practice them over here. You can really see that over here as well. And then you apply them to targeted official questions. And this is how every module is structured. So it allows you to cement your understanding or strengthen your understanding right then and there. Again, when you look at the architecture of the Magoosh course or pretty much every other online course, what you're going to find is that feedback mechanism is not built in place. You don't get that instant feedback. Over here, you see just one quiz at the bottom. And essentially there's no score. Why? The intent is to just give you practice and not to give you feedback. Now, some of you may be saying, why is it important that I get this feedback right away? Because the reason why you're studying divisibility and remainders is not because you want to learn divisibility and remainders. It's because you want to hit that targeted ability level. Once you hit that targeted ability level, or you know that you are well on that 720 journey. The last piece is evaluation of mastery. So you saw how we evaluated you at concept and application level. At a cohort level, which is, let's say, number properties or inequalities, we also evaluate you. So we have these ability quizzes which you can take, which, once you're done with algebra, you can take just an algebra ability quiz and it'll give you an ability score. What's more is that it'll also tell you what is the causing that ability score, and in this case, that 64 percentile in algebra is primarily because you're not doing as well in inequalities and functions, and so it allows you to figure out areas where you need to focus on. Once you have those areas defined, you can go revise those concepts and essentially come out with flying colors. So while you learn the same content in these two approaches, you can really see how that personalization benefits more and ensures that more and more people, as they go through that private tutoring based approach, reach their target milestones and hence their target GMAT scores. Who's created this content? Some of GMAT Club's top rated instructors have created this content, and you can actually go and look at the instructor reviews. Instructors who've been reviewed a lot more frequently on GMAT Club. So while only 6% of the people score 720 or higher, a good percentage of them do use e-GMAT. With that, I've come to the end of my introduction. If you want to stay updated with all things e-GMAT, I would recommend that you connect with me on my LinkedIn. Actually, right now I have about 10,000 plus students connected with me on my LinkedIn. We do post a few articles every week. We do post any product updates that we have every week as well. With that, let's go right into the core of the webinar, which is how to ace algebra. So this webinar is divided into 3 parts. In the first part, we're going to solve some very basic questions, some questions which I would call as 500 level questions. And the goal of this first part is to make sure that you have the foundation to solve more challenging questions. Once we solve the basic questions, we are going to go into 600 and then 700 level questions. And as we go into 600 and then 700 level questions, we are going to expose the gaps in your understanding. We're going to expose your faltering points or your faltering areas. And the consistency throughout this session is going to be that we're going to have the same process of solving questions. When we solve equations, you're going to see a consistency over there. So if you're able to go through the basic, if you're able to solve the foundation questions, you'd be able to solve the 600 and 700 level questions as well. But in the event you're unable to solve the foundation questions, I would recommend that you log into your e-GMAT account and do the foundation concept files that we sent your way. But for those of you who are already prepped to a certain degree, the output is going to be this piece over here. It'll tell you the key gaps in your preparation. It'll tell you where you're faltering. It'll tell you why you're faltering. It'll also tell you that acing GMAT Quant is not about knowing the math. It is about reducing or minimizing the areas where you falter. So in terms of progression, we're going to cover these concepts, but we'll have a warm-up quiz with 6 questions, and they're all going to be problem solving. Then we'll have 9 questions, which are 6 plus 700 level questions. So we'll solve about 15 questions on this webinar, which is quite a few questions, and so we will follow a certain pace. Okay. Again, this is the warm-up section. Make sure that you have a pen and paper ready. So I'm going to mute myself for about a minute so that each one of you can get a pen and paper ready. Once you guys are ready, I want you to select this poll which says yes or no. I want you to select yes. Once I know that 70 to 80% of you have selected yes, we will move forward. So if you have a pen and paper, if you have a bottle of water there with you, then we'll move forward. So If you have that, please select yes. All right, I need a few more students. I need at least 70 people to select yes before I move forward. All right, 62, 66, 69, 70. That's wonderful. Thank you very much for the participation, guys. So let me put in the poll questions here for the first question. And here is your first question. All right, last 15 seconds, guys. Let's get those responses in. 5, 4, 3, 2, and 1. Let me end the poll. I'm going to briefly broadcast the results. 87% of you answered it correctly. We're going to discuss these questions, but we're going to do 3 questions first. Here is your second question, and here's the prompt for the second question. All right, guys, last 15 seconds for the second question. All right, get those answers in. 5, 4, 3, 2, and 1. Let me end the poll. Broadcast the results. 76% of you got the second one right. And again, we'll discuss this. For this third question, I will give you 2 minutes. So this is slightly more challenging. You'll have more time. So don't rush through this one. All right, you'll have 2 minutes starting now. All right, guys, you have had 2 minutes 23 seconds. Let's get those responses in. 5, 4, 3, 2, and 1. Let me end the poll. Okay, good participation. Thank you. And again, for those of you who have not responded to any of the questions, just you're here spending your time. The best way to get feedback that is personalized to you is to make sure that you participate. That way, you take a side. So before I show the solutions, I want to make sure that for those of you who've solved these all three of them correctly, wonderful. For those of you who've not, just take down the points where you made a mistake, because we're going to test the same concepts again and again. So if you faltered on something in any of the warm-up questions, make sure you don't falter on the same concept or the same faltering point later on. So let's start with the first question. This is the first question. I'm going to show the responses. Again, 87% of you did it correctly, which was really good. So choice B was the correct answer. Essentially, all you had to do is move y on one side, or add y to both sides if you want to do it that way, and then move 10 on the other side. And essentially, you would get this equation, divide by +5 on both sides, and you get this inequality, which is y is greater than -2. For those of you who chose A, you guys somewhere switch the sign of inequality for no reason. Remember, when dividing by a positive number, we don't switch the sign of inequality. So you made that mistake. So other than that, if you've chosen choices C or D, I think that's something that you have to figure out. You probably made a calculation mistake. All right, choice B. Choice B, again, 75% of the class did it correctly. Choice B, we just incrementally moved forward. All we did was we added two inequalities. Again, basic knowledge of inequalities, all we had to do is solve two inequalities. The answer again is choice B. All you had to do is multiply the first inequality over here by 2, which leads you to this 2x minus 2y is greater than -6. Then you add the two inequalities. As you do that, what you find is x gets cancelled. You basically get left with y is greater than -2. That's all there is. Again, 25% of you faltered over here. Can you guys tell me, for those of you who faltered? Yeah, here's my short answer poll. Where did you falter very quickly? For those of you, the 25% of you who faltered, where did you falter? Okay, write down your mistakes. It's one additional step towards what I call as redemption. Did not look for -6. Okay, you made again. Write down the steps on a piece of paper. That's the first good habit that you develop. As you are doing these questions, show your work. As you're doing this question, show your work. All right. Switch the sign. Again, show your work. Chose the answer in the grid. Please write it down. Look at the grid properly. Okay, that is good. Okay, let's go to the third question. The third question was tricky and yet not tricky. And I'll talk about why I really say that. It was tricky in the sense that the language of the question was a bit more complex. It wasn't tricky because the math actually was simpler than the math required in question number 2. So let's kind of look at that over here. What you were given were two inequalities, and you said how many non-negative integral values of m does the two inequalities satisfy. So all you had to look was solve for them and look at the possible set of values and only look for non-negative integral values. Okay, so let's kind of do the solving. Is actually the math is very similar. It's the non-math, or reading the question and understanding what the question is asking for, is what is a bit more complex. So this is where you have a GMAT-like problem, not a classical math problem, but more of a GMAT-like problem over here. So essentially what you do is the inequalities are actually very nicely laid out for you. Just add both these inequalities, and what you get to is 4m is minus 4m is greater than minus 10. How many of you were able to get to this? Minus 4m is greater than minus 10. All right, 71% of this class were able to get to this point. Or if you talk about pure numbers, 46 of you were able to get there, yet only 28 answered it correctly. So let's see where you guys faltered. The others who are not able to get to this point, I would strongly recommend you need to build that foundation. If you're making mistakes over here, you have an issue with foundation. But 71% of you were able to get there. Then what you had to do was, if you did something like this, that is a mistake. Because when you multiply an inequality by a negative number, what do we do when we multiply an inequality by a negative number? What do we do in the short answer port? We flip the sign of inequality. You reverse the sign, and which is what you needed to do over here. Okay, so you multiply by minus 1 and you flip the sign of inequality. And for those of you who can't see this, you can really see this as minus 4m is greater than minus 10. When you multiply it by minus 1, the inequality is flipped to 4m is less than 10, which means m is less than 10 by 4, or there are three possible non-negative values of m, which are 0, 1, and 2. So only 41 or 42% of you answered this correctly. 58% of you did not. And tell me, and also write it down in a piece of paper, where did you make a mistake? Where did you guys make a mistake over here, even though 70% of you got to the core equation? Forgot about 0, okay. Very nice. And it's non-negative. And that's where you had to focus on the term non-negative. Did not flip the inequalities. So I think that's where reading and understanding the English is equally important when it comes to acing GMAT Quant. The question that you had to ask was, even if you weren't sure, is 0 negative? If the answer to that is no, then it is non-negative. The phrase will distract you, and that's one thing. This is a GMAT-like question, not a quant question. But this is a GMAT quant question and not a math question, is what I would say. For those of you who forgot 0, make sure you take this down, and next time when you see the word non-negative, you don't use that. For those of you who basically were distracted by the phrase, make sure you read slowly. And for those of you who did not flip the sign of inequality, make sure you write it down. When multiplying both sides by a negative number, I need to flip the sign of inequalities, which, by the way, you'd be successful in doing if you show your work. Okay, very good. We now have three more questions at the foundation level. Let's get those out. Here is our fourth question. All right, guys, last 20 seconds. Get those answers. 3, 2, and 1. Let me end the poll and broadcast the results. 67.5% of you, around about 68% of you got this correct. That is good. Now we're going to have the next question over here, and then we'll discuss both these questions. For this question, for the next question, which is warm-up question 5, I'm going to give you 2.5 minutes. So don't panic, solve it coolly. Here is the next question. All right, guys, last 5 seconds. Time's almost up. 3, 2, and 1. Let me end the poll. Broadcast the results. 56% of 53% of you, I think, answered it correctly. If I remember the correct answer, I haven't solved it myself this time. So let's kind of look at the solutions over here. We'll look at 4 and 5. So essentially, what you're given us is a fairly standard inequality math question. So there's no GMAT quant over here. It's a standard question, a foundational question. It says, what's the range of x for the inequality? X minus 2 and x minus 3 is greater than 0. What you have to really say is, hey, where the product of these two terms is positive. Okay. So you ask yourself, when can these two terms be positive? There are two ways in when they can be positive. One is when both of these terms are positive, or when both are negative. So all you need to do is find the range of of values of x for which either both these products are both these terms are positive or both of them are negative. Why? Because the product of two negative numbers is a positive number, and the product of two positive numbers is also a positive number. So for this condition, both of them need to be greater than 0 for both them to be positive, which means x needs to be greater than 3 overall. How many of you got this part? That x needs to be greater than 3 for both these terms to be positive. All right, almost 90% of you got this. That's wonderful. Now for both of them to be negative, both of them need to be less than 0, which means either over here x needs to be less than 2, and over here x needs to be less than 3. The most stringent is that x being less than 2, which means the two conditions which are there are either x is less than 2, which means 2 to minus infinity with 2 excluded, or x is greater than 3, which means 3 to plus infinity with 3 excluded. Okay, so 66% of you got this right. About 33% of you made a mistake. Can you guys tell me where did you make a mistake? Where did you falter? Forgot the negative condition. Okay. Did not understand the answer choices. All right. Okay. What else? Remove the brackets. Okay. All right. So again, take down these notes. Make sure you don't forget this going forward. This is basic math that you need to know to solve the most challenging questions which are going to come your way. Let's get to the next question. Next question is essentially where you got 54% of you got it correct. Now over here you have another approach to this as well, which is the wavy line approach, which again gets you this answer. So we have an article on wavy line approach which we'll be sharing as well. Now the next question, warm-up question, which is you have a fraction and it's saying for what range of values of x, what is the range of values of x if this fraction x minus 3 divided by x plus 4 is negative. Okay, so the first thing which really starts when you see a fraction is you need to simplify it, or rather I'd say there are two approaches to solving this. The first approach is you can really take conditions in numerator and denominator the way we did in the prior question in product of two terms. Now it so happens that taking conditions in numerators and denominator is not as scalable. You can do it for a simple question such as this one. As the expressions start to get more complex, it starts to become a bit more tricky. So then some people, what they do is they start to multiply the denominator on both sides, because what you have is a 0 over here. Okay, so the question really is, can we multiply both sides by x plus 4? The answer to that is no. Why? Because we don't know what x plus 4 is. Is it positive? Is it negative? We have absolutely no idea. So what we do is we multiply both sides by x plus 4 whole square. Why? Because the square of a term is always positive. And when we know that, hey, when we multiply both sides of an inequality by a positive term, we don't need to worry about what? When we multiply both sides of an inequality by a positive term, what do we not need to worry about? The sign. We don't need to worry about changing the sign of the inequality. It remains the same. So because it's square of a number, we know it's going to be positive. Okay, so what you get is you get the product as x plus 4 multiplied by x minus 3 is negative or less than 0. Once you have that approach, it's the same as the previous question. You look at the 0 points and you really say which areas are positive, which areas are negative, and what you find is that this inequality is negative in this range minus 4 and 3 with both the terms excluded. All right, so I gave you plenty of time for this question. Where did you guys falter? It's both the sides excluded. Okay. Did not multiply with the square of denominator on both sides. Okay. All right. You multiplied rather by x plus 4, and then that gets you the problem. So now you know you can't multiply an inequality by a number that can be both positive or negative. Why? Because you're not sure. If you're very sure that it's negative, you can multiply it and change the sign. If you're very sure it's positive, you can multiply it and change the sign. But if you're not sure, then you can't do that. Did not understand the answer choice. The answer choice, the correct one, does not have infinity in there. Choice C is the correct one, and it does not have infinity. So essentially, let me just move on. And again, I'd appreciate if you put the questions in the Q&A pod. That way, Ashutosh can get to them. So essentially, if you want to approach this equation by a fundamental approach, what you really say is this is negative when either of these terms is negative. And if you take the conditions, what you're going to find is that between 3 and minus 4, these terms are negative. So if x is equal to 2, then x minus 3 is negative, x plus 4 is positive. And when x is equal to minus 3, what you find is that x minus 3 is still negative and x plus 4 is positive. So the product of these two numbers is less than 0. So which is why you see this this wavy, this essentially, let me just see this. I can't draw a curve using my annotations. So you see the wavy line graph. Yes, minus 4 is not actually a solution. It is excluded. Minus 4 and 3, both of them are excluded, because remember, when x turns to 3, what happens? It's no longer less than 0. It is equal to 0. Jasmine, is that clear? You can apply this approach to all fraction questions. Again, remember, the approach really is you're multiplying it with a definitive positive or a definitive negative number. If you're multiplying an inequality on both sides with a definitive positive number, you don't need to flip the sign. If you know that number is going to be negative, then you have to flip the sign. So what we're looking for is something that's deterministic. Okay. And again, if you have problems understanding things, you haven't gone through the foundation concepts that we sent your way, because the foundation concepts do cover this. All right, with that, let's talk about the last foundation question. Last 10 seconds, get those responses in. 3, 2, and 1. Let me end the poll. Let me broadcast the results. 76% of you got this correct, which I'm going to just briefly breeze through this then. Essentially fairly standard in, absolute value question with inequalities or absolute value inequalities. Over here, what you're given is you're given this absolute value. It says x plus 3. Absolute, for which of the following inequalities it's equivalent to the absolute value of x plus 3 to be less than or equal to 5. Remember, both of these are included, which is why you rarely see the equal to sign in the correct answer, or in actually pretty much all the answer choices. So there are two ways of doing it. One is you say, hey, x plus 3 is z. So what this inequality reduces to is that z is less than or equal to 5. And when that happens, if you want to just do it the very fundamental way, you just visualize this on the number line. And what you really say is, hey, this is essentially a span of 11 units starting from 0. So going from -5 to +5 with everything included, the 11 possible values that this inequality could take. So now the inequality reduces to z is between +5 and -5. You replace z by x plus 3, and essentially you add -3 to both sides, and you really get this. Essentially, this is the more fundamental way of doing this. If you only understand what a modulus means, this is essentially the mathematical depiction of the modulus, and you get to this answer. For those of you who are a bit more advanced users, what you really say is, hey, I'm going to represent this inequality in the standard form, which is x minus a is less than or equal to 5, which means that it is at a distance of 5 on either sides from a point of -3. Okay, so you start at -3 and go 5 on either side. So this is a more slightly more advanced way, just a slightly more advanced way of doing it. You get to the same result. So with that, we have come to the end of our foundation questions. These questions were designed to make sure that you understand what you need as a foundation to be able to solve 600 level questions, which would be the next set of questions overall. Okay, make sure that as you do this, as you've gone through these foundation concepts, that the concepts that are tested over here, you're 100% clear on those. If there are areas where you faltered, that you've written down those areas, and essentially, as you solve the next questions, try not to make the same mistakes that you made in the foundation concepts. Okay. As we get to the next question, I don't like to time people. What I like to do is I like to really time the entire group. So what I'm going to do is I'm going to ask you to choose have not solved yet. Okay. So that way I will know how many people are actually going to be solving this question. I have 108 students in the webinar. I want at least 80 of you to really select have not solved yet. That way it allows me to time this entire group. And then from a timing standpoint, what I'm going to do is I'm going to put in this pod over here, which is what we call as a notes pod, and I'm going to really tell you how many percent of the class is done. So here right now, for example, 0% is done. So let's get 70 of you to really say have not solved yet, guys, so that we can move forward. I only have 55 right now. Let's get 70 to say have not solved yet. 60. Let's get 10 more. 66. 10, 4 more. 3. 2 more. To say have not solved yet. Come on, guys. All right, perfect. I'm going to remove broadcast results. Here is your first question. Hey guys, 80% of the class is done, so I'm going to give you another 15 seconds. All right, 5, 4, 3, 2, and 1. Let me end the poll. Broadcast the results. Choice C, the correct answer, 52.2% of you marked choice C. Let's see the approach. None of the above, actually the second most popular choice. So what you're given is a fairly simple inequality, and it's asking you for a range of x. Okay, so you're given this inequality. What do you form? So whenever you get this question or a questions such as a real GMAT question, tell yourself what is it that you're given and what is it that you have to find. Even though it may seem mundane for some questions, if you get into the habit of doing that, as you get to solving more tricky questions, you will not falter. And you're going to see that as we move forward. And ask yourself, okay, is there a constraint? And over here, there's no constraint on the values of x. It can be integer, non-integer, it can be positive, negative, anything. So all you do is take the inequality, rearrange the terms, get all the terms with x on one side, get all the terms with numbers on the other side. How many of you were able to do this? %97 were able to do this. If 97% of you were able to do this, then you should have gotten this question correct. This simplifies to minus 32x is greater than 64. How many of you were able to do this? If 100% of you were able to do this, then 100% of you should have been able to get this right. So we multiply by minus 1 on both sides. Remember, you're multiplying by with a negative number. When you do that, you change the sign of inequality. If you don't change the sign of inequality, you get to this answer choice, which is x is greater than minus 2. Remember, over here, we have not changed the sign of inequality. And you will choose choice. Actually, you won't be able to choose any choice. Or you'll choose choice this or A or B if you've chosen that, and very few if you've done that. When you multiply by minus 1 on both sides, you flip the sign of inequality and you get to this x is less than minus 2. When x is less than minus 2, what you really say is, hey, x is between minus infinity and minus 2, which is your choice C. So even though 98% of you got to the right, formulated the right inequality, only 52% of you got this correct. So where did you falter? Where did you make a mistake? There's nothing called a silly mistake. It is a mistake. Don't tell yourself it's a silly mistake and then give yourself a pat on the back to really say, hey, you almost did it right. X is less than minus 2. Yes, it means the same as minus infinity to minus 2. Yes, because minus 3 is less than minus 2, minus 4 is less than minus 2, and so on and so forth. And the person who says, I looked at the inequality and saw the right hand side was 3 times greater, so decided no real solution could be found. Again, you're being lazy. Don't do that on the GMAT. It will eat you. People who design questions, they spend hours trying to trick people like you who really want to be lazy. Don't be lazy on the GMAT. Show your work. Okay? Don't do that, please. All right, let's go to the next question. You guys know the drill. I'm going to clear all answers, but write down the takeaways. Clear all answers and select have not solved yet, please. Oh, let me reopen the poll. Select have not solved yet, please. So as we go now, the questions will start to become progressively more challenging because we are in the realm of real questions. So mark have not solved yet. Okay, I still don't have 70 people saying have not solved yet, guys. I need to get 70 people saying have not solved yet. I only have 64 who've chosen one answer choice or the other. I would recommend everyone choose have not solved yet. 67, 68, 69, one more person needs to put in a response. Let's get to 70. All right, we are at 70. Here is your next question. Okay. All right, guys, 85% of the class is done. So I'm going to give you guys another 10 seconds. 3, 2, not 850, 85%. Silly me. All right, and 1. Here's what I love about this question, and here is what I hate about this question. Okay, I'm going to end the poll. Sorry, I don't know how the broadcast results went away, but can you put in your responses again? Can you just put in your responses once again, guys? My apologies. Yep, we have pretty much the same responses. So here's what I hate and what I love about this question. Okay, 80+% of you, and I'm going to end the poll, broadcast the results. If you chose choice A or B, you should have answered this question correctly. Okay, 80+% of you could have answered this question correctly. Yet, very few answered this question correctly. Let me just tell you why. Is there a constraint in the question stem? Yes, x is an integer. What is the minimum value of integer x? For those of you who chose choice A, is minus 5.5 an integer? Is that an integer? The 34 people who chose choice A? And that's what GMAT Quant is about. It's not about the math. The math is simple. It's about reading these constraints. It's about following them. It's about following the process and writing this down. There's nothing in math where you faulted. 84% of you did the math right. Only 40.5% of you got the GMAT aspect right. So you got to the minimum value, just did not look at you solved the inequalities correctly, did not look at the integer piece. So you say, hey, this is what's given, the two inequalities. My goal is to find the minimum value of x. Then you ask yourself, even before you start solving, is there a constraint that I need to worry about? And then you really say, hey, x is an integer. Okay, you already solved the first inequality in the previous question. You solve the second inequality, and you say 2x is greater than or equal to minus 11. What does that mean on the number line? Which means x is greater than or equal to minus 5. Okay, so you start with minus 5, which is included because of the equal to sign over here, and you go all the way to plus infinity. But because of the other inequality, which says that x is less than minus 2, you say the range of values of x is these. And then you really say, hey, there are three possible integer values, minus 5, minus 4, and minus 3. And you say the smallest integer value is minus 5. If you chose choice D, or if you chose choice E, which by the way, you guys did, you made a silly mistake. The minimum value is minus 5, not minus 3 or minus 2. Minus 2 is actually not even allowed. Tyler says, will the GMAT include the equations that are unnecessary? We do not need the first inequality. Tyler, you do need the first inequality. It's not unnecessary, or you don't know that it's unnecessary till you solve it. If you're given two inequalities, one of the things that the GMAT is testing is for the minimum value, which one is the constraining piece. Okay, if you look at the first inequality, what did it say? X is less than minus 2. If that were the case, what is the smallest value of if you were given just this inequality? What is the smallest value of x? It would be close to minus infinity. Then the integral value which is closest to minus infinity. So it's not an unnecessary equation. Okay. So the next question. Again, I'm going to show you the next question. As I said, we are going to go up in difficulty level. It may seem complex, but it is the easiest question to solve. So what I would recommend is first of all, take away, uh, write down the takeaway points that, okay, I'm going to read the question carefully. I am going to follow the constraints. And then show your work, show each and every step. Do not start solving the question till you understand the question. Okay, let's select have not solved yet so that we can go forward. We still have another 8 questions to solve, guys. So click have not solved yet. I have 53, 55, 60. I need to get to 70. These are 6 to 767. Really good. Let's get 3 more. 69, 70. Perfect. Let me remove broadcast results. Here is the next question. Again, you may be scared, but if you read the question properly, it'll be a very easy question for you. You won't even have to do a whole lot of math in this. Okay. All right, 80% of the class is done. Let's get those answers in 3, 2, and 1. Let me end the poll. I'm going to broadcast the results, and I would say, 70% of you could have answered this correctly, yet way fewer have answered it correctly. All right. So the first thing, in this expression that is given to you, this expression is a product of two numbers. So z square plus 4 and z square minus 2. So let's call this 1. And let's see if can I really do yeah, let's call this 2. Let's call this 2. Can any of the expressions be just positive or just negative? Which one? And why? Which one and why? Expressions, not numbers. I know minus 2 is negative. 1 is positive. Yes, let's understand 1 is always positive. Let's understand why that is the case. The correct answer is choice D. 30% of you got it. So what you're given over here is you're given this expression. Okay, and what you're asked is to find the range of values of z square, not z but z square. Okay, so if you tried if you chose choice E, what you found was the range of values of z. We want is the range of values of z square. Okay, then you ask yourself, is there a constraint? No, there isn't a constraint. So let's kind of solve the inequality. We're given a product of two expressions, and we said find the range of values of z square where that product turns negative. Okay, the constraint, there's no constraint given to us, but what we know is that the square of a number on the GMAT is always positive. Z square is non-negative, which means it can be equal to 0 or it can be greater than 0. Since the smallest value of z square is equal to 0, which means z square plus 4 is always greater than 0. Can everyone understand that? Z square plus 4 is always greater than 0. Why? Because the smallest value of z square on the GMAT is 0. Square of a number, the smallest value of square of a number is 0. Why? Because in the GMAT, for those of you who are more mathematically inclined, on the GMAT we live in the real world. We don't include imaginary numbers. Imaginary numbers do not exist on the GMAT. Imaginary numbers are an imagination of physics and science, not business. So again, Ankita, remember this and repeat after me. There are no imaginary numbers on the GMAT. For those of you who don't know what imaginary numbers are, they are a figment of imagination of scientists, and the square of an imaginary number is -1, or I square, which is called iota square, is -1. But essentially what you need to remember is that a square of a number in the context of GMAT is always positive, because on the GMAT we only deal with real numbers, not complex numbers. In the real world, we only deal with real numbers. And if I remember correctly, who said? Saket, I is probably square root of -1 if I remember my engineering days correctly. Okay, is it absolutely clear that z square plus 4 is always greater than 0, or z square or a square of a number on the GMAT is equal to or greater than 0? Alright, let's move forward. So since this is always positive, we are left with this expression that z square minus 2 is negative, which means z square is less than 2, which means the range of values of z square is between 0, which includes 0, and 2. Very simple. Choice D. For those of you who did this, you actually did way more work without worrying about, hey, z square cannot be negative, or z square plus 4 is always positive. Okay, what did you learn from this? Write it down on your piece of paper. Write it down in the short answer pod before we go on to the next question. What did you learn? Come on, let's get some answers. Implicit constraints, rarely. Can z square be 0? Yes. What if z is 0? What will be the square of 0? All right, put this down. Remember this. Okay, now let's go on to the next question. Reopen poll, you know the drill. Remember these constraints as you solve the next question. The next question is a related question. Okay, I want to make sure that more than 60% of the class gets the next question right. If you take the learnings down from this question to the next question, 60% of you should get it right. Okay, have not solved yet, please, 70 people. Get that in right away. Next time I should say you should also have a pen, paper and coffee with you. That way, when we are an hour and a half into the webinar, you guys are still awake. Or at least a good chunk of you are still awake. We get to that 70 number a lot sooner. And I know, 60% of the class is from Asia over here, and so it is getting late. But essentially, that's where you pull that last ounce of energy. That's where you really, essentially, really find that energy in you. Okay, I'm going to remove broadcast results. Thank you for that energetic participation. And we already went through the solution. That is good. Here, what just happened? Hold on. Yep. Here is your next question. I'm going to reopen the poll. Here is the question. Let's get to the answer. Right, guys, 85% of the class is done. Get those answers in. 3, 2, and 1. Let me end the poll. I'm going to broadcast the results. 68% of you got it right. The answer indeed is 2. So let's look at what the question is saying. It's giving you a constraint that z is an integer. And then it's asking how many values of z square, not z, satisfy this inequality. Okay. So when you look at this, it's the same inequality. And you say, hey, z square has to be less than 2. And again, let me just go through. Last time I messed up because I did not go through the presentation as it was intended. Let's just go through question number 4. How many values of z square? Okay, so the constraint is that z is an integer. We are given as this over here. Okay, we substitute z square as x, and we know that x has to be greater than 0. Okay, since z is an integer, z square, the only two possible values of z square are z square could be 0 or z square could be 1. Okay, so how many values of z square are there? 2. Good number of you got it right. That is perfect. Now, let's do an overview. Again, what we did over here was, if you look at and understand, was there any complex concept that we discussed over here, you'd find that there was none. In the first question, what we did was, well, the only thing that we looked at was that we changed the sign of inequality. All right, we change the sign of inequality when you multiply it. Okay, let me just look at some questions over here. Let's just go back. Walid says, what about minus 1? Z can be minus 1. Can z square be minus 1, Walid? Remember, the question is how many values of z square? Okay, if you were asked for the number of values of z, then you would put minus 1, not z square. Remember, z square is always positive. Okay, let's do an overview of questions 1 to 4. What we did was some very basic things that we want to make sure that we get them right. When you multiply an inequality by a negative number, you change the sign of inequality. We always remember that a perfect square is non-negative on the GMAT, and you apply the wavy line method, which we did in question 3 as well as in question 4. These are the conceptual things that we learned, and these are the only conceptual things that we applied in these questions. Now, the other things that we applied, we always simplified an equation to bring it to a known form. In question 3 as well as question 4, we substituted z square as x, and that's one way of doing it. Okay, we read the constraints, question 2 to question 4. That's the biggest area where people falter. You have to read the constraints, both the given constraints, whether something's an integer or not, as well as the implied constraints. And that's kind of where, if you do this, most of the math on the GMAT is fairly simple. And read the question statement properly. In question 4, it was asking for the range of values of z square, not z. Look at this again. Read through this, because you're going to have to apply all of this as we move forward in 700 level questions. And I want you to choose have not solved yet once again. Let's do have not solved yet, because we are going to switch gears. I need 70 people to choose have not solved yet. $66. Let's get 4 more. 67, 68, 70. Perfect. Thank you very much. Here is your first question. Read it properly. Understand the question stem, then go on solving the question. Alright guys, get those answers in. Time's almost up. I'm going to give you another 20 seconds. Three, two, and one. Let me end the poll. Let me broadcast the results. So, as we get into 700 level questions, the math more or less remains the same. The math does not change. What changes, there are a couple of things that changes. One is you see more constraints. The second is that the question asks you to follow a couple of more steps, which means the math is not any more difficult, but in terms of from your starting point to your ending point, you may have one more step at least, and which means you need to carry on the information from one step to the other. That's the only thing. The math that you would see in this question is the same as what you've been doing so far. So first things first, are there any constraints over here that are given to you? What are the constraints? X and Y are both positive integers, which means they are greater than 0. The second thing is we need to find the positive difference between the minimum possible values of X and minimum possible value of Y. So this question is full of constraints, and you have to read this really carefully. Okay. So first of all, X and Y are positive integers. The second is you need positive difference, and the third is the difference has to be between minimum possible values of X and minimum possible value of Y. Okay, how many of you got all three of these constraints? Okay. And again, this is just reading the question stem. There is no math. It's all English so far. And that's why I said, sit down, read the question first. You will have ample time. You guys spend about 4 minutes on this question. Okay, so when you do something like this, you say, hey, what is given to me? Same process. What's given to you? You're given these two inequalities. Their signs are different. So one's greater than, the other one is less than. But the inequalities don't seem terribly difficult. They seem very manageable. Then what is it that I need to find? I need to find the positive difference between the minimum value of X and a minimum value of Y. What do I know? I know that by solving the inequalities, I can get the minimum value of X and the minimum value of Y. That's something that I can be very certain. What are constraints? That X and Y are both positive integers. Okay. So before you start solving, you need to have that vision towards the end goal, which is, what are you going to do? You're going to first express the inequalities in the standard form so that you can solve them. Then you're going to solve the inequalities. Then you're going to find the answer. To find the answer, you're going to first find the minimum value of X and the minimum value of Y, which comes from solving the inequalities. And then you're going to find that positive difference. And then you're going to choose the answer. So let's do that. Let's put them in the standard form. The standard form is ax plus by plus c is greater than 0. We do the same thing with inequality 2 as well, and you see inequalities which are marked 1 and 2 are the ones in standard form over here. Once you brought them in standard form, we need to really make sure that either x or y cancel out. And in this case, what we are going to do is we're going to cancel x out. To do that, we're going to multiply 1 by 3. And as you do that, you change 1 to 3x plus 6y minus 60 is greater than 0. And then you get number 2 over here. So you have 3x and minus 3x over here, as you can really see. And so x cancels out. And you get y is greater than 6. How many of you were able to get to y is greater than 6? "85% of you were able to get to y is greater than 6. 85% of you should have marked this answer correctly. You did the math right. Where you faltered is not math, it's English. Then you solve for x and you get x to be less than 8. Remember, you have to flip the sign when you multiply by a negative number over here. Okay, you have to flip the sign. And you get x to be less than 8. So if y is greater than 6, which means y is 7, 8, 9, blah, 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 and x has to be less than 8, so then let's really see. Then you say, okay, now I know I've solved these inequalities. Now let's figure out the minimum possible value of x and the minimum possible value of y. Because x is less than 8, the minimum possible value of x is 1. Why? Because both of them are positive integers. And the minimum possible value of y is 7. How many of you got this? How many of you got this? Minimum value of x is 1. Minimum value of y is 7. And I'm sure a bunch of you faltered over here because you did not apply the constraint that x and y are positive integers, which means the minimum possible value of x cannot be minus infinity. If you chose choice B as the answer, which by the way, let me just get in your poll results. 24% of you chose choice B as the answer. Then you took the maximum value of x, which is 7, and the minimum value of y, which is 7 as well. Okay, do not do that. Minimum of x is 1, and you would have done that. So the difference is 7 minus 1, 6. Rishi says, why is minimum of x in this not 0? Because x and y are positive integers. 0 is not a positive integer. Rishi, does that help? 0 is the unbiased integer is what I would say. It's not a positive integer, it's not a negative integer. Okay. So tell me one thing, where did you guys falter, or what did you learn from this? Both. Where did you guys falter and what did you learn from this question? Because the math in this was fairly simple. So Ruchika said, and great question Ruchika said, in the earlier question we considered 0 as positive. No, remember the language in the prior question was non-negative integers. 0 is non-negative, but it's not positive. Ruchika, there's a difference. And that's where you need to be very clear with these foundational things. Okay, pause. Again, you are not faltering on the math. You are not faltering. You're faltering on the GMAT side of things, not on the math side of things. So So that's kind of where you need to stay calm. You need to focus on reading the question very, very clearly. Actually, constraints tend to be more important. Understanding the constraints, writing those things down, is the difference between a guy who gets a Q40 and a Q50. Okay, so inculcate those good habits. Okay, so let's do the next question. You guys know the drill. Let me reopen the poll. Choose have not solved yet. Write down the learnings from the prior question. Okay, 52, 53. Guys, let's get to 70. 55. 0 is not a positive integer. Okay, 50. I have about 60 people who put in the poll response, guys. Let's get a few more. Let's get 65. Get 5 more. $64. One more before I show the next question. 65. Very nice. Thank you. Here is the next question. Again, this will look very scary, but if you focus on simplifying this, think of how you can simplify this even before you start solving. You'd be able to answer this question very easily. All right, guys, I will give you 1 more minute. Stay focused, continue. All right, last 15 seconds. 5, 4, 3, 2, and 1. Let me end the poll. I'm going to broadcast the results, and what you're going to really see is every answer seems to be in contention. There's no clear winner. In fact, if I remember the answer correctly, the correct answer is the least popular one. So, but it's a difficult looking question. It's not a difficult question, it's a difficult looking question. And one thing that I'll tell you is there are two kinds of people. When people look at this question, they react in two possible ways, and how they react is what determines whether they end up scoring a Q50 or a Q50 Q48. There's a group of people, so many people don't get this question, okay, and it doesn't matter whether you answer this correctly or not. What matters really is your attitude towards this question, and and um, and so there's one group of people who really says, hey, this is super difficult. I'm not going to solve it. This is not likely to come on the GMAT, so let's not worry about it. And those are the people who go on till Q48 if you've done all the questions right, but don't get to that Q50. You may do Q49, won't get Q50 or 51. Then there's a second group of people who also are not able to solve this question, but they really say, okay, let me figure out what is an optimal way to solve this question. Let me learn from this. And even if a question as difficult as this one doesn't come over there, what may happen is there are learnings from this question that I might get that I'll choose to apply, or that will help me solve other questions more easily. And that is the group which with hard work gets to Q50. So I hope many of you are in that latter group. So I'm going to show you the solution to this question. As I said, it looks scary. It's not scary. Okay, what you're given is these two scary looking inequalities. There are two things about them. They are in squares, and you have one of them which has a greater than sign, the other one has a less than sign. So they don't seem completely uniform, but essentially they are in R square and S square. And if you look at them, they look super scary. You really say, hey, what do I do? Do I take the LCM? Do I really just multiply this with something? I don't know. I don't have an approach. And again, the question is a fairly standard question, which says, hey, what's the overlap zone for R and S, even though the inequalities are given in R square and S square? And then you ask yourself, is there a constraint on the value of R and S? And you say there is no constraint. So your process should remain the same. You should express the inequalities in a standard form. You should solve them and identify the overlap zone. Once you identify the overlap zone, that is your answer. Now, we don't know how to solve inequalities in fractions. What we know is how to solve linear inequalities. So that's what we're going to try and transform this to. So we substitute 1 by r squared as x and 1 by s squared as y. And when you do that, the first inequality becomes this. Does this look a lot more simple? Yes, it looks a lot more like the standard form, right? Let's do that with the second inequality and express it in the standard form. Again, the standard form is ax plus by plus c is greater than 0. That's what we did. Remember over here we multiplied this by -1. As we did that by -1, we changed the signs on both sides. You can really see this is changed from less than to greater than. All right. So let's continue to solve. Well, my first inequality is again x minus y plus 9 is greater than 0. And again, if you're wondering where did the denominator go, when you substitute 1 by r squared as x and 1 by s squared as y, you can really see this. The denominator is gone. So we are left with these two inequalities. Then what we do is we add them because we need to solve them. And once we add them, y gets cancelled and you get x is less than 16. You add 3 and 1. So this is minus x plus 16 is greater than 0 and 1 is this one, and you cancel x and you get y is less than 25. Okay, very manageable inequalities. So you get x less than 16, y is less than 25. I'm going to give you guys 10 to 15 seconds to look at it, and again make sure that you're able to follow me. Select yes if you're able to follow me till this point. Because if you're able to follow me till this point, then you pretty much can solve this question now. It has now become a fairly easy question. All right, pretty much everyone's able to follow me. When you say x is less than 16, let's substitute x as 1 by r squared because that's what it was. So which means 1 by r squared is less than 16. Now r squared is a positive term, 16 is a positive term, which means we can swap them. Okay, which means r squared is greater than 1 by 16. Or r squared minus 1 by 16 is greater than 0. Are you guys with me once again? Okay. The one person who can't follow me, or two people, can you put your question in the Q&A pod, and Ashutosh would be happy to respond to that question as to where you can't follow me. Remember, r squared is positive, 16 is positive, so you can just swap them without changing the sign of inequality. Okay, so r square minus 16 means r square minus 1 by 4 whole square is greater than 0, and a square minus b square is a minus b into a plus b. We just express that. Can you guys follow me now? This is a beautiful question if you think about it. And once you have it in this form, okay, you can easily represent it on the number line. So we did the same thing for s square. You guys can do the math, but it comes out to this s minus 1 by 4 and 1 by 5. And this is how we represent them on the number line. So don't worry about s right now. Let's just worry about, let's not worry about s. Let's just worry about r right now. And Let's not worry about S, let's just worry about R, and R said R minus 1 by 4 and multiplied by R plus 1 by 4 is positive. And for that, for R, actually let me just move this over here. For R, what it really means is if you use the wavy line method, it's negative from minus 1 by 4 to plus 1 by 4, and it's positive outside it. And that's kind of your region. For S, now I'm going to move this over to R. So S minus 1 by 5 and S plus 1 by 5 is greater than 0. 1 by 5 is 0.2. So S is more is under this over here. So R is more restrictive than S. So the overlap zone is defined by R. Okay. All right. Manas says, why can't we square root both sides? And the answer is yes, you can, and that way also you'll get the plus minus. It's just our way of doing it, and I prefer that way, Manas, but good question. You still have to do the plus minus constraint. And when you express it in this form over here, S plus 1 by 4, S minus 1 by 4, you basically are able to get the overlap zone a lot easier. Again, it was a long question. No doubt about that. But from a math standpoint, there weren't many things in that question that you did not know already. So what did you learn from this question? And Neda, what does overlap zone mean? It means the zone in which both inequalities are valid. That's your overlap zone. Need to practice the basics more. That's good. It's easy when it was converted to X and Y. I can display the answer choices once more. Here are the answer choices. Choice A is the correct answer. Absolutely. Is there anything else? Ankita? How do you decide in doing the overlap zone? So overlap zone between two inequalities, you always take the more restrictive ones. So if you really see minus 1 by 4 is outside of minus 1 by 5. So inequality, let's call this inequality. So inequality in S is also valid at minus 1.4 or minus 1 by 4, but inequality in R is not valid at minus 1 by 5. Okay, so R is much more restrictive than S. On the GMAT, you do not get a calculator. On the GMAT, you don't get the calculator, no. One thing that you have to do is you also have to test the test maker that you actually get a scratch pad on which you take notes, basically. You get a scratch pad. So one thing that you have to do is make sure you test the test maker that the question that would be given to you would be a correct question, would not be a question that is uber difficult. And if you find that the question seems uber difficult to you, then you're not approaching it correctly. All right, so what we'll do is we'll solve two data sufficiency questions. And once we solve two data sufficiency questions, we'll then end this webinar. Okay, so just two data sufficiency questions. We're going to breeze through them really quickly. That way you will get a chance to taste data sufficiency questions as well. But one thing hopefully that I have impressed upon you guys is that the math here is not difficult at all. It's fairly elementary. Once you have the basics, it's purely about learning the application. Okay, let's get 50 people to really say have not solved yet. And I know for people in Asia, it's getting really late. It's just get that last ounce of energy, guys. Just bring that last ounce in, and I promise you it'll be worth the while. Okay, let's 48, 49. Let's get one more 50. That is great. And here is your first data sufficiency question. Okay, and it's an absolute value, so we're switching gears a bit, but let's solve this. If you're still hung on the previous question, you will get the PDF. It'll help you solve this. And then if you're looking for alternate approaches, try solving using an alternate approach and see if you get to the same answer. All right, guys, 80% of you are done. Last 10 seconds. 5, 4, 3, 2, and 1. Let me end the poll, and I'm going to broadcast the results. So remember, this is not a difficult question. It says 600 level question over here. We are changing gears. We are kind of going back into absolute value. The most popular answer choice is choice E, which says each statement alone, statements 1 and 2 together are not sufficient. Now, one of the things that you have to really do in absolute value questions, and this becomes more and more relevant to absolute value questions, is when you're given a statement, and you'll be given three statements sorry, it becomes more relevant to data sufficiency questions, is that when you're given a DS question, analyze each statement properly or independently. So first analyze the question statement and extract all the information that you can extract out of it. Understand what is it that you need to solve. Then analyze this statement and really see whether this alone is sufficient, and then analyze this statement and analyze this independently. After you've done that, and if you feel the need to combine the statements, then you combine the statements. So let's kind of look at this over here. The question that that's been asked is that, hey, you're given that z is an integer and you've been asked that z is positive. Okay, what is the constraint? The constraint is that z is an integer, and the other constraint is that the absolute value of z is less than 6. What it really means is, given that z is an integer with an absolute value less than 6, if you draw the number line, there are 11 possible values of z, starting from -5 to +5. How many of you were able to, get to this inference purely from a question statement? There are 11 possible values of z, starting from +5 to -5, both of them included. All right. Now that we have this in mind, we go forward and we really say, hey, the first statement says absolute value of z minus 2 is greater than 3. Essentially, what it really means is that if you write this down, that z minus 2 is, or it doesn't mean that you can write it down because of the greater than sign. That is not true. So you have to take both the conditions. Okay. So when you say z minus 2 is greater than 3, you basically have two possibilities. One is either z minus 2 is greater than 3 if this is positive, or z minus 2 is less than -3 if z minus 2 as an expression is negative, and you have to take both cases. When you do that, when you take z minus 2 is greater than 3, then you get z is greater than 5, or when you solve this side, you said z is less than 1. How many of you were able to get to these two conditions, that either z is greater than 5 or z is less than 1? Less than -1, I'm sorry. 75% of you were able to get to this point. All right. So those 22% who were not able to get to this point, where did you falter? So this is a fairly standard application of standard value of absolute value. Where did you guys falter? The 22% who weren't able to get to these two. Okay, +3 -3 did not take both the cases. Okay, didn't consider the negative part. All right. Okay, that is good. So tell me one thing. Can z be greater than 5 given the constraints that we saw? Can z be greater than 5? No, z cannot be greater than 5 because z is between +5 and -5. Since there's no integral value of z between 5 and 6, we really say, hey, all values of z are negative. Okay, which means statement 1 is sufficient to give me a reliable answer whether z is positive or not. And the answer to that is no, z is not positive. If 74% of you were able to get to z is greater than 5 or z is greater than -1, why were you not able to get to this answer that statement 1 is sufficient? Forgot to apply the constraints, missed the integral value. Okay, Again, it's the same learning that we are carrying on from the very beginning, and you can see how you repeat the same mistakes. You did the math, you did not do the English. Let's look at z absolute value. Let's evaluate statement 2 independently. Absolute value of z is equal to 2, which means z could either be plus 2 or minus 2. Both of these are valid values. Remember, z could be any value from plus 5 to minus 5. Since there is a positive and a negative value of z, statement 2 is not sufficient by itself, but statement 1 is. Okay, and since statement 1 is sufficient, the correct answer is choice A. Ruchi says, what about minus 4? Minus 4 is a valid value over here, but all values are negative. So we can reliably answer the question, Richard, that the z is not a positive integer. Remember, the question stem asked, is z positive? Okay, now we're going to do the last question for the day. Let me clear all answers and bring you your answer poll. You guys know the drill. Select have not solved yet. All right, I have 50 responses. I'm going to show the next question to you. Here is the next question. This is a 700 level question. Again, simple question, very logic driven question. Take a All right, 85% of the class is done. I'm going to give you guys another 5 seconds to put in your answers. 5, 4, 3, 2, and 1. Let me end the poll. I'm going to broadcast the results. Only 7 people answered this correctly. If I remember correctly, choice C is indeed the correct answer. Now, this is a beautiful question. It's a 700 level question. There's no elaborate math required here. It's pure logic, and that's the beauty of this question. So look at this carefully. What is the question stem asking? The question stem is asking is whether B is greater than A. And again, when you read stuff like this, you have to put it in simple English. It's always easier when you put math in simple English. Okay, and so what it's asking is whether B is greater than A. You have to tell with 100% certainty whether B is greater than A. Is there a constraint on values of A or B? Positive, negative, integer, non-integer? No, there is no constraint. Okay, there's nothing much in the question statement, and you have to really just understand that it's asking whether A is greater than B or whether B is greater than A. Okay, and you have to be very definitive about it. So the first statement says absolute value of A minus B is equal to B minus A. All right. So what do we know about absolute value of a number? Let me just put in the poll question. What do we know about absolute value of a number? In very simple terms, there are two values of an absolute value expression positive. Okay, absolute value of a number is always either positive or equal to 0. It's not always positive, it's either positive or equal to 0. Okay, it's a distance between two numbers which could be 0 or positive. It's always non-negative. How many of you missed the 0 part over here? How many of you missed that? So again, here is the foundation. If absolute value of x is y, then y is equal to y is a non-negative number. Okay, so what it really means is y is either equal to 0 or it is greater than 0, but both are possible. So what this really means is, since absolute value of a number is greater than or equal to 0, what it means is b minus a is greater than or equal to 0. Or in other words, b can be equal to a or b can be greater than a. B cannot be less than a, but b can be equal to a or greater than a. Do you guys get both of these answer conditions from here? No math, simple logic, just logic. There are two possible answers. Either b is equal to a or b is less than a. Okay, because absolute value of a number can be 0. If absolute value of a minus b is 0, then this means a minus b could also be 0. In that case, b would be equal to a. All right. Now, can we reliably answer the question, is b greater than a? No, we can't, because both of these answers are possible. So clearly, statement 1 is not sufficient. Now let's look at statement 2 independently. What does statement 2 say? It says a divided by b is less than 1. Okay, so let's evaluate that. There are two cases. One is if b is positive, and the second case is when b is negative. Okay, there are two scenarios that exist. If b is positive, which means, then that clearly means that if a by b is less than 1, then b is greater than a. Okay, if b is plus 2 and a by b is less than 1, then B has to be greater than A. If B is negative and A by B is less than 1, then A has to be greater than B. And again, what this really means is statement 2 is not sufficient, but again, as per statement 2, there are two possible conditions. Either B is greater than A or B is less than A. Which condition is not possible as per statement 2? Which condition is not possible as per statement 2? A is equal to B. And of course, B is equal to 0. Well, B is equal to 0 is still possible in some ways, but A is equal to B is not possible. Okay, so then let's combine these two. As per condition 1, A can be equal to B or B can be greater than A. As per condition 2, the equality doesn't exist. Either B has to be less than A or B has to be greater than A. So when you combine these two, you really say, hey, there's only one common condition in which B is greater than A. And then you combine that and you really say, hey, when you put both the conditions together, you get just one answer, which makes statement C, both statements together are sufficient as the correct answer. A lot of you chose choices A and B, and if you chose choices A and B, you guys made silly mistakes. Over here, you missed the constraint that it can be equal, that absolute value of a number can be equal to 0. Over here, you missed the constraint of you did not consider the positive and negative cases together, or you potentially did not consider the negative case. Again, understand where you faltered. As a question, this is a fairly this is a question based on logic, not on math. And then to answer this question, all you needed to know was what does absolute value mean? One of the things that I want to emphasize on over here is when it comes to GMAT Quant, it's not about really learning the math. The math by itself is fairly simple. If you have a low quant score, all you need to know is you need to master the basics, and then you need to A, follow a consistent process, B, focus on understanding the constraints, and C, apply the process diligently by showing your work. Okay, and if you practice and make sure that you make fewer and fewer mistakes, you can go from a very low quant score to a fairly high quant score. If you're someone who thinks he was good in quant but is stuck at a certain score, again, by focusing on these things, you can get there. Here's an example of a guy who scored 740, and he was someone who really thought that he's really good at math. And yes, he was good at math, but he wasn't good at GMAT Quant. And essentially, he would get to a Q48, but wasn't able to go beyond a Q48. And he says the reason that was there was because I knew the math. I did not know the GMAT aspect of it, and hence he was solving more and more challenging, more and more involved questions that had a lot of math, but not a lot of GMAT. Okay, he was faltering in data sufficiency questions, and essentially he would just, the moment he would see variables, he would put in values over there, and he would fall in all sorts of trap. As he practiced more questions using the e-GMAT methodology, as he applied, as he improved consistently, he was able to get off that trap and was able to get to a Q51, which is what he ended up with. Here's another case of a student who got into Wharton, and he improved from a fairly low quant score. Okay, he was unable to cross Q45 despite working really hard. He actually even took some private tutoring. What helped him get to Q49? Again, lessons that we talked about in this webinar. Apply the constraints. Infer from the question statement. If there's information given over there, there are some implied constraints and there are some explicit constraints. Make sure you infer both of them. You also use a lot of analytics. So our Scholarinium platform has over 1,200 questions, and when you solve questions, we actually collect analytics on areas. So he used that data to isolate his weakness. And then we have this custom quizzing feature in our Scholarium platform where you can create quizzes based on your areas of weakness. He was admitted to Stern, he was admitted to Tipper, he's studying at Wharton right now. Here's an example of a guy who started from a very low quant score at a Q30, which is 20 percentile, and was able to improve to 45, Q45. And the reason he was able to do that was because of the progressive nature of the course, where with the concept file you get easy questions, and then the questions start to get more and more difficult. And he was able to go from a Q30 to a Q45, which is incredible. And there's another guy who improved from Q38 to Q50. Again, these are low scores to Q50 is a really, really high score. And the reason, again, he was able to do that was because he focused on learning. He wasn't taking mocks every third day. He focused on learning the concepts. He went through the course and essentially he used data to make sure that he can see where his improvement is coming from and which are areas where he still had to work on. And by you following this consistent process to figure out the areas that he still had to work on, he was able to get to the score. Now, one of the things that was there was he wanted to study at Wharton, but because it's such a quant-focused school, at Q38 it was not even Wharton didn't even consider him. But once he got to a Q50, with his other extracurriculars, he was able to impress the folks at Wharton. So essentially, if you want to ace GMAT Quant, you don't need to solve a lot of do a lot of math. You just need the basics in place. Once you have the basics in place, you need to just inculcate good habits. And to inculcate good habits, you need focused practice. You need solutions that isolate the mistakes for you and tell you that these are the areas that you need to work on. You don't need shortcuts because shortcuts don't work on the GMAT. So as next steps on the concepts, make sure you are absolutely clear. Make sure you show your work. Solve questions in a step-by-step fashion. You infer information from the question stem. Create a journey towards, okay, this is what I'm going to do in step 1, step 2, and step 3. Write down all the equations. Express the inequalities in standard form. You've got to become an active reader of the question. You know, when you see a question, don't just read the math, read the logic behind it as well. And the last question, the way we said, what it's asking is absolute value, whether B is greater than A or not. You read that, you understand when you're reading that question stem. A lot of people, while reading the question stem, they'll look at the next statement. They're already looking at the next statement while they're doing that. Don't do that. When you do that, you will not understand the logic that the question is trying to pass on to you. A lot of people think that oh my God, the questions are fairly complex. You know, you've got to trust the test maker. He will not throw anything that's super complex, that requires a ton of calculation. And if you have the foundation, believe that you have everything that you need to solve such questions. With that, with regards to the next steps, make sure you do the files in the free trial. They are there. Please do that. There are some practice questions that I'm going to share in this PDF as well. And you have some questions in Scholarium, even if you're a free trial user. Do those questions. All right, with that, I'm going to stop sharing. And I'd appreciate if I could get some feedback. Okay, so here's the session PDF, and then if you could rate the session, that would be great as well. Over here, if you could rate the session over here, I'm going to open this poll. I have a very interesting question. No one has actually asked this question in a very long time. Ole says, out of curiosity, if you were to take the GMAT tomorrow without prep, what would you expect to score? That's a really great question, Ole. So I asked this question myself again and again, so I will tell you the detail. If I were to take the GMAT tomorrow, and I've been out of touch with GMAT Quant for some time, but GMAT Verbal I stay in touch quite frequently. So on GMAT Verbal, my guess really is I'd score anywhere from 98 to 97 to 98 percentile. I probably won't get to 99 percentile on verbal. On GMAT Quant, I'd either get to a Q48 or a Q49 if I were to take this tomorrow. Now, if I got 4 days to prepare and 4 days, I am very certain I can get to a Q50 and get to a 99 percentile on verbal. If I get about 10 days to prepare, I am more or less certain that I'd be able to get back to a 780 or so. But yeah. And I want to thank everyone who's put in this amazing feedback. Thank you very much. All right. The question says, can we guarantee a score of 740? No, I cannot, because it's you who has to study. I can tell you, when you look at the stats over there, that our success rate is much higher than success rate from any other prep company, and I can tell you why that is the case. But yes, you have to study. If I could guarantee a 740, I'd probably be charging you 40 to 50 grand in dollars and not in rupees. So, but because again, it's your effort. As a company, our philosophy is to sell our courses at a price which everyone can afford, and so that we make this amazing learning available to everyone out there. Our standard deviation and probability asked a lot. Probability not a whole lot, but you do get standard deviation to a certain degree. Kamal says, can we get into Wharton with 710 with 3 years of experience? Kamal, it depends on what the quality of that experience is. It depends on whether you're an international student and whether you're an international student from a country where you know, which is a crowded pool. So for example, an Indian with 710, unless and until you have some amazing work experiences, is not likely to get into Wharton. The example that I showed was that of a South American. So, so for South Americans are not a fairly common pool at Wharton. And the guy had really good a really good profile as well. And again, when you watch the interview, these are 30-minute unedited interviews. You can really see how the person approached the admission at Wharton, and you'd get a lot more learning to it, not just from how these folks prepared for the GMAT, but also how they've approached various B schools and how they think about B schools. And in engineering, how much work X in Wharton or Harvard? So again, remember these that I can tell you pure numbers, but there's this there's a lot more that sits there. So for Indian students, typically 740 or higher scores are I'd say the average scores at Wharton. You'd need about 4 years of work experience, but the quality of work experience also matters. How you perform in the interview also matters. Okay, the fact that have you shown leadership during your work ex, that's something which is really good. Here's an example of hey, how can you show leadership, which is something that B schools really value. And here's how you can show leadership overall. All right, I want to thank everyone for giving me feedback. I can really see more than half the class gave me a perfect 10, which was wonderful. Um, and again, for those of you who've given me a 7 or an 8, I'd try to do better next time and see if I can get better scores from you. Also remember, we have the reading comprehension webinar next week as well as the quant workshop. You can register for both of them from the e-GMAT website or if you log into your e-GMAT account. With that, I want to thank everyone for joining me today. It was a pleasure conducting this webinar. Go through the concept files in the free trial and make sure you make the most of this webinar.